Hello, pretties. Welcome back to another C programming video. God damn. It's been a long time, huh? Let me just do my hair a little bit, just to make sure it doesn't fall. There we go. Has been quite a long time since we've programmed in C, but hopefully you still remember this, right? Right here. We've basically finished explaining what buffers are and how much memory allocation. So if you want to see this and recap this, obviously I have a video on my channel that goes through all of this already. So just watch that video. Just go and watch that video, for God's sakes. Like, come on now. We're gonna continue. Obviously doing this. And we're gonna today. So I want to talk. We're gonna continue obviously where we left off last time on the last video, and obviously. So today we're gonna talk more about getting input from the user and just printing and stuff. I also want to talk with you a little bit about user-defined functions because I think you might know, but well, I'm just gonna briefly mention some user-defined functions, return types and stuff. So I think one of the most important data types in C will be void. So this will be the most important this one right here is really important, right? So this is a really important data type. It's called void, which basically means there is no real data or real type associated with the variable. So this will be used for anything to pass in like parameters, to passing in like, let's say, return types. So as you can see here, this right here, this is where we use void. So void, this right here indicates that there are explicitly no parameters that we want to use with our main function. Obviously we can change this to int arg counter, and then we can just say char double pointer arg vector. So the reason why char is a double pointer is because it takes a pointer to a list of char pointers, right? So let me just briefly mention this. I think so. This we can. I'll mention this in another video on C. This double pointers shit. But so far, all you need to understand that this is two parameters that we are passing into a function, and if we are passing none, you can do it like this. But ideally, in C, the convention is to write void here, just to make it explicit that there is no parameters being passed into this function. It's just by convention, really, that this is what you should be doing. So let's talk about user-defined functions, and I also want to take you through input-output and file descriptors. So we're going to talk about how get and how print function works. We're just going to talk about how that works, and we're just going to do some basic input-output, maybe printing stuff into a file and then reading stuff from a file. Because all input and output handling in C is basically just a pointer to a file. Like, that's all it is. They're all files, right? So, for example, 0 would be stdout, 1 is stdin, and so on and so forth, just like you have had in assembly, where you move the 1 to racks or 0 to racks to basically like choose whether or not you want to, I think it was racks, right? To choose whether or not you want to basically print or get input from a user. So something similar will happen here, but we'll get to it when we get to it. So let's define let's first talk about functions in C. So functions are basically, they are basically pointers to locations in memory where code should start like being executed from. So essentially they're just pointers, and every function has a return type. So you can have int or void, and then you have a function name, and then you pass in parameters, which could be either int or void, and then obviously you have the function body, and depending on your return type, it returns a function. We use the return keyword, obviously, just like we would in C++. So let's write our first function then. So last video I have talked about arrays as well, so we'll talk about them a little bit in depth today later. But let's just write our first function that prints something to the console, right? So let's say void, and maybe we just say, hey, maybe this is gonna be just a test function, and here we take no parameters, so we're just gonna say void. So this is how our function will look like, right? So this is our test function. It doesn't return anything, and it obviously returns no parameter, and obviously has no parameters. So let's just print something. Let's just print, let's say, let's print hello, right? No fuck. There we go. And we call the function equally as we would any other function. So test. There we go. And we compile and run. There we go. As you can see, we print hello to the console. It's pretty simple, pretty easy. There's nothing really much to explain with functions. I mean, they're pretty primitive. I mean, this is the simplest functions you can write. Now I wanna the simplest function you can write looks like this. I'll also talk a bit more about function pointers while we're doing functions, but we're gonna get to that when we get to that. So there we go. So let's try writing like a function that initializes an array of integers, right? So last video on C, I've talked about how we can make an array of integers like this. So this is an array of integers, right? So like this. So we can declare an array, for example, numbers like this, using the square bracket operator, and then here we can put the length, not the size. Remember? Remember the whole thing, how I said length, not size? So here we input the length. So how many numbers do we want to store in this array? So I want to store 3 numbers. And then we use the curly brackets called an array initializer list. And then we put 3 numbers here. So this is how we can, this is one way of initializing an array. And another way is to pass it to a function. And this is where we are going to combine our knowledge from the previous video of kind of having this square brackets and this pointer are like equivalent, and we're going to show why they are kind of equivalent, but also why they're not. For example, we can also initialize this array. We can also leave this uninitialized, obviously, and then we can initialize it with a for loop. So let me actually show you. I'm not gonna just talk about it and theorize. I mean, actually show you how I would go about this. So let's just imagine that you have an array, right? So it's an int, and then we have numbers, right? So numbers, and we put the square brackets here that we want an array. Well, array of 3. So one way we can do it is just simply use the array initializer list like we used last video, and then simply use a for loop to print all of the numbers, right? So maybe we can, let's say, print, I don't know, let's print numbers 0. So this is gonna print the first number in our array, which will be 1. So there you go, 1 is printed. Good. So this is one way of initializing an array in C. So you can use your array initializer list that basically says, hey, I want to initialize this array of length of 3 with these numbers in these curly braces. But there's another way to do it, and this is where we talk about functions. And another way to do it, a good way for me to like teach you about functions in C a little bit, well, we're going to use a function for this. So we're just going to leave this uninitialized. So we're just going to have an uninitialized array of 3 numbers. We can kind of leave this uninitialized because you're going to be replacing. But obviously I don't want garbage to be... we could leave this uninitialized, But if we only initialize, let's say, indexes 0 and 1, the other two are going to have random garbage in them, which obviously isn't very useful. We want, the entire array to have zeros, like 3 zeros. I want this uninitialized array to contain 3 zeros to kind of initialize it, or like prepare the memory inside of this variable for writing. I want to have 3 zeros, so if I only set numbers in this array, for example, the first two numbers, so to 1 and 2, if I say index 0 and index 1 to number 1 and 2, I want the other two numbers in this array to read 0, 0, and not some random garbage, right? Because that would be more clear to us and more useful to us, rather than just having a bunch of random numbers in there that don't mean anything. So again, we're going to be using the memset function. I've explained this, I've touched upon this in the last video because it's kind of important. So this is how we can kind of prepare this array to basically be written to. So let's do memset, and I'm going to explain the void pointers in this video. So last time I skipped over the void pointer, but right now I'm actually going to take you through all of these parameters. So this takes a void pointer, and what that means is that it basically takes in a pointer to a memory location it sets to 0 of any type. So of type X. So this could be an integer pointer, a char pointer, a long pointer, you get me. So void pointer is basically a wildcard of a sorts. It basically just says a pointer of any kind can be passed into this parameter. So void pointers can be cast to any pointer of any type. And a pointer of any type can be casted to a void pointer. So void pointers are kind of special. So basically this parameter is basically just telling you, hey, I need a pointer, any pointer. It doesn't matter what data type, any pointer will do. Int, char, long, whatever. So it just basically tells you, like, I want any pointer, like any pointer of any kind will do. Which we do have. We have a pointer called numbers, so there we go. This is our pointer, and this int parameter right here that you see is basically just like, hey, what value should I set this memory, the values at this memory location? Like, what is the value? So basically this parameter is asking you, like, hey, so you have inputted the pointer to a memory location that I should set to X, and this parameter is asking you, like, hey, what value do you want me to set this memory to? Well, obviously we want to set the data in the memory to 0. And then the size here is basically asking you, hey, what is the size of the memory that you want to set to 0? Like, what is the size that I'm working with here? Usually how many bytes of data do you want to set to 0 or whatever, right? It basically just wants the size of the memory location. Now, this is a bit weird because you can't... It needs the bytes. So this is in bytes. It says specifically size. And we can't just use the size of operator here, and this will not be 3. So what we need to do here is basically... So this would be 3 times 4, because it's integer. So this is the size that you actually want to set. But in this case, the size of operator should work. This should give us 12, I believe. So, because we're using the square brackets, right? This is gonna work. If I was explicitly using the int pointer like this, it wouldn't work. Like the size of operator wouldn't work because you're just trying to get the size of the int pointer rather than the actual array. But here this will work. It should work. I think this will work. So now if I basically go here, so now if I basically say print me, for example, the first number in numbers, it should say 0. So here it should basically say 0 now, if I got this correctly. Yeah. So as you can see now, we have prepared our array for usage. So now we can use this. Now it has meaningful data in it. Now it basically has data that actually means something to us. We can easily now actually go and use this array. I'm sorry, I'm talking like a bit of a primitive, but yeah, so now we can basically use this array and basically work with it. So we have 3 zeros in our array, so let's write a function that writes into the array and prints our array for us. So obviously we don't want to be doing any for loops in our main function, right? That's not the way we should be doing this. So let's write a function that writes some data into our array. So maybe, I don't know, that writes some, yeah, so it writes data into our array. So this function, you need to also think about what it should return. So what data do I need back from this function? Well, it just simply writes something to this array. So we don't really need a return type, so we can just keep this void for simplicity's sake. What else? Well, let's name it set array data. So let's name it like this, and parameters. Okay, so now I'm gonna stop you. This is where I'm gonna kind of talk about how these are equivalent. This is a pointer in and of itself. So this array is basically treated as a pointer if you are passing it as a parameter to a function. So you can't pass the actual array to a to a function. You instead, what you do is pass a pointer to an array, to a function. So here, if we want an array to set data to, specifically we want to set int array. But if you want to generalize this, you can basically say void pointer array, because this is going to be able to take array of any type, right? But for now, we're just gonna say int pointer. So we want to specifically set a data or to an array of integers for now, just to keep things simple, just to not confuse people with it. So we also have to pass the length of the array separately. We can't just use, so here, this is where the problem is. We can't use a size of operator on this. So this is sized, right? Int, this is sized. So this is a sized declaration, which means that this is sized, which means that you can use size of operators. So anything that ends with the square brackets, you can use a size of operator on. Now, if you initialize it a bit differently, so let's say if you use the malloc or calloc function, where you're dealing with raw pointers like this, for example, this is not sized. So this is not sized, which means that on this you can not use size of right here, size of, because you're not actually getting. So if you do, let's say here, if I, for example, initialize numbers, let's say numbers to 3, if I then do size of numbers, this will work because this returns the amount of bytes, aka 3 times 4 bytes, right? But that's because we used the square brackets initializer right here, so we explicitly said 3. So we gave it a sized, so we declared it in a sized way. So this is not sized, which means that if you use the size of operator here, so if you do size of, let's say, sorry, oh, what am I doing? My freaking hair is like everywhere today. Good lord. So if you use size of, so for this, you do size of like this array. this is not correct. So this is not correct, because actually if you do something like this, you're not actually taking the size of the array. You're actually taking the size. What you're actually doing is size of int pointer. So you're actually basically you're basically saying to the computer that, hey, give me the size of the int pointer. So this is actually what really it looks like when you do something like this. You're basically just getting the size of the int pointer, which will always be 4 bytes. So this will always equal to 4. No matter how long this array is, doing this will always give you 4, which will fuck you up, obviously, if your array is actually larger than the length of 4. So you will experience some really weird undefined behavior. So don't do this, okay? So if you want to actually pass this to a function correctly, you need to give it the length of your array that you're trying to set separately. So let's give it a const int length, right? There we go. So this is the correct way of doing it. So we have a pointer to an array that we want to set some arbitrary data to. And we also have, let's say, a length of the array that we pass in separately, because we need to pass the little 3 here, because we have 3 elements. So that would be the number of elements, basically, that we're passing. And here we can basically put our for loop right here. This is how we would do it correctly. So basically, right here, we would basically say for int I equals 0 right here. And then I is less than length. So that would be length and I++. So this right here is the correct way of setting something, an array, to a data type correctly in C. So then what we do is, since the pointers are subscriptable, obviously, we want to just say array I, and we want to set data at position I to something. So let's say I+1, right? So let's do I+1 for now. Let's keep this simple, you know, for you, because this is intended for people who have never programmed in C, so I want to keep this really simple. So there we go. So we have a for loop, and we're basically saying that, hey, at every position I, we want to set that data to I+1. That's basically what we are saying. Always make sure, if you want to pass in an array, always make sure that you pass in the array as a pointer, like so, and the length of your array if it's not a char array. So char pointers are an exception. Char pointers are an exception. You can use the strlen function to check the length of a char array. That's the reason why char pointers are like a special things. That they are very special in that sense that they don't work like other pointers of other data types. They work very differently, and they work differently. So yeah, so this would be your pointer right here, and this would be your length. It's a const int because this is how we can make it const, because it never changes. So you should declare this const, and this will work. So this should work, right? And this will work. I can already tell you that this will work. So this is gonna 100% work. So I don't know. Maybe if you go and follow me with this, and maybe try this yourself, and then run it. You put this right into the first parameter, and the 3 right into the second parameter. So maybe if you can try and run this on your own PC. I'm gonna, in the meantime, write up a function that will print our array, which is also very simple. Obviously, there are no range-based loops in C, so we have to basically get around that. So void, let's say, get array data. Let's see, get array data. We want to basically have. So here, I'm sorry, I'm yawning, but here we basically want to pass in an integer pointer right here, array, and obviously we want to put const in length. So we want to obviously put length as well into here because there are no range-based loops in C. So we have to always provide the length as well. You always need to be specific when you're programming in C. Okay? So 0, I is less than length, just like before, I++, so this would be your normal for loop. And then let's just do array I right here. Basically, we want to use just the printfs function if you have it, which will basically take in our format, which is going to be a D for integer. And what do we want to print? We want to print array at I. So this will basically get the data at position I from our array. Now we can try out our functions. So if you haven't tried it before, let's try them together. So let's try these functions together. As you can see, it really is just a simple little for loop. So yeah, it's just a simple little for loop. That is nothing to worry about. These are very similar to like Python or other programming languages. Very, very, very simple so far, obviously. We are not gonna, yeah. So here, what we want to do is we basically just want to call our functions now. So first we want to set array data, and it will ask you for an int array. So that would be numbers. So we want to say this, and then in this case, const int length, that would be 3, like so. Or you can just use size of numbers. In this case, it will work. But yeah, since this becomes a pointer without the square brackets included here. And what we want to now do is, well, when we set data, we also need to get the data. So let's get array data. And here we provided in an array that we wrote into. So that would be, let's say, numbers again. And then again, the size is 3. So so this is basically how much data do we want to print. Obviously, I can put here 1 or 2. Like this is basically we're printing off data. So ideally, if you want to print the entire array, it should be the same. So if anything, I should probably get size of, no, this is the length. So length is 3. So no size off, that would get size. So this is length, not size. So this would be a length of 3. And here we will now see that it should give us 1, 2, 3. And indeed, it gave us 1, 2, 3, as you can see. So if you got this far, now you know how to set data using user-defined functions and how to get data from arrays with user-defined functions. I'm also going to basically show you how we can use a void pointer for any data type, because this one is strictly int. So this one requires an int pointer strictly. But then we can say also void get data any. So here we can pass in something called a void pointer to a data set, and then here we can pass in the const int length of that data set. And here we can basically loop through it like so. I is less than length and I++. So always make sure that your lengths match up. So here we basically we can only print either a string or an integer. So this is kind of meaningless, because if I just say D, it will just print like, yeah, I mean, the thing is that this is in void data type, so we don't really know what to print here. So if we just say D for now, it will basically, I think, complain about it. Yeah. Yeah, so it's incomplete. So we don't really have any data declaration. We could probably set the void data type though to something. And then if we would print it, it would have to be just like, yeah. We could probably like set data to it. Yeah. Could probably do that. We're probably gonna have to cast it. Yeah, so this is like anything. So we can't really assign to it or read from it because we don't know what type is being passed. So we're gonna have to do some typecasting. Okay, that's a bit too advanced for this tutorial though. We're not really gonna we haven't really talked about typecasting yet, so we're gonna do that when I'm gonna go through typecasting with you, because you have to do typecasting when you do work with void pointers. Yeah, so we'll just move on from that. We'll just omit that for now because we're not gonna talk about typecasting in this video. So yeah, so for now I'm just gonna try and teach you do these simple concepts. So for now, always just declare what data types do you want to assign and read from. That's good for you right now at this level, okay? So yeah, and so I think that's done with user-defined functions. I think that would be it for user-defined functions. What else did I want to cover with you? So I wanted to cover, yeah, so we did the user-defined functions. Oh yeah, the file IO as well. Oh, of course. Okay, so yeah, I wanted to also cover file IO as well. And file descriptors. Yeah. So I'm assuming that you've already had a chance to test this out. Feel free to experiment with user-defined functions a little bit. Like, you need to go and do that for yourself. Oh, by the way, I am planning to make a little series for C, C++, and C#. So we're gonna have like a little programming series for all three C languages. So that should be fun. But yeah, so now what we're gonna do is we are going to take about files. So we're gonna this file struct, which is very important. So in C, we have a bunch of file descriptors. We have stdin right here, stdin. As you can see, this right here for Windows, it's a replacement for something called ACRT IOB func0. So this is basically like the file descriptor for a action. As you can see, this is basically like in assembly how you move 0 to a certain register. So that's kind of what this is. So it's basically just an IO buffer function. 0 means input, 1 means output, right? So if I do stdout, it's gonna say 1 in that little ACRT function. As you can see, it says 1. Just like moving 1 in assembly means standard out. And standard error should be 2, I think. Yeah, so as you can see, 2 is standard error. These are the same numbers that you move in assembly. For example, how you do like move 0 to racks or move 1 to racks. So this is exactly kind of similar to that. Okay, so these are called file descriptors. 0, 1, 2. 0 being input, 1 being output, and 2 being standard error. So if you basically remember how I talked about the printfs function, this function automatically prints to standard out. So this function automatically prints to 1 to standard out, right? If you wanted to do this properly, you would use the fprintf function, this one right here. So this is actually what the real actual function looks like. So this is the main function that prints to standard out. It's just the printf function automatically assumes that you want to print to standard out, but fprintfs prints to any file stream basically. As you can see, it takes a file pointer. So basically, if I wanted to emulate like how the printf function works, I would basically say std out here. I would put my format specifier here, and I would put hello world into this var argument right here. And this is basically how the printf function works. And as you can see, it will print hello world, just like a printf function. Fget fs will take standard in file descriptor, and here this is where we can also print a standard error as well. So this function can also print a standard error. This is an error right here, so it will appear red in our console, as you can see right here. So this is what standard error looks like. So this is how we can print to different streams, output streams basically, using these macros defined right here. So we have built-in file descriptors, which would be std out, std in, and stdr right here. Standard out, standard in, and standard error. All going from 0, or going from 1, 0, 2. That would be the file descriptors for standard out, standard in, and standard error. Right there. So this is basically how this entire process works. So we always work with file descriptors. It's all about the files. So the real meat on the bones when it comes to C is the struct called file. This basically allows you to output your program results to different parts in your computer. So for example, we can output stuff instead of to standard out, we can output it to a file that we of any choice. So how do we do this? Well, we basically need a file pointer, so-called file. Okay, so this is basically how we declare struct file. So, file pointer to a file. So we need some kind of stream. And these file streams are called basically data streams. So these are data streams where we want to send data to. Now, I'm going to use the fopen. So fopen is we open a stream to a file, right? Fopen. So we're going to use the fopens, which takes a file double pointer file to a file, which is achieved by simply preceding our little file right here with an ampersand. So like this. So it's a double pointer to a file. Right here, then we basically just say the name of our file, which would be, let's say, hello.txt, and open mode. Open mode will be append. There we go. So this is how we basically open a file. Open a new stream in C. So well done. You have now opened a new custom file stream in C. Now this will allow us to write our output of our program to this little file. So we use fprintf, right? So instead of saying std out right here to print to console, we simply just provide the pointer to our file struct like this, file, and we basically say, oh, I want to print a string, and I want to print hello world. Hello world. I want to append hello world to our file, right? So this is basically what we're gonna do. Then obviously we want to close the stream, so we say fclose, and then this takes a pointer to our file stream. So file. Can you see how this goes? So we make a file struct, we declare a file pointer right here, which will basically be our stream where we want to write data to. We open the stream by passing the file by reference or giving the memory address of the pointer. So we're basically giving this function the memory address of the pointer to our file stream, not the memory address of the file stream, the memory address of the pointer. Remember, that is very, very important. So that's basically what this first parameter is. The double pointer, the IOBuff pointer to stream. So there, it's a double pointer essentially. That basically is a pointer, a memory that basically is a pointer to a pointer. Essentially, if I were to translate that, it would basically mean a memory address of a pointer to a file stream. That's basically what we want as the first parameter. Therefore, we put the little ampersand there. Then obviously this is easy. We name our file, we just pass in the name what the file wants to be, and we just append any text to it. Then fprintf, instead of putting std out here, we put file. It's basically the std out and file in this case are the same thing. They're both file pointers, or basically just file descriptors. That's basically what they are. So that's why we can do this. And we basically just print hello world to the file, and then we need to make sure to close our stream. Always make sure to close your streams, just like in Python or any other programming language. You always need to close your streams, just like you would close your sockets. Okay, so let's test this out. So let's run this. Good. Our program finished executing. So now we're gonna have a look if we actually found a file. So we go debug, and there it is. Look at that. Hello. Why is that there? Excuse me? What the hell are you doing, boy? Anyway, well, it clearly did work. It worked right here, as you can see. Yeah, there we go. Hello world. I don't know why it says hello world here. I don't know. It's motherfucking weird. Can we delete this? I specifically said hello. Maybe I have this. Let's say. Maybe I should probably. There's append and write. I know there is append mode as well. Come on, you bastard. Work. I should work. I'm sorry, I'm yawning. There we go. Look at that. We get hello.txt right here, which is from the previous one. And here, which is right here. So we got it, dudes, right there. So it's hello world and hello right there. What are you doing, boy? So there we go. As you can see, we pass in the file name. It creates the file if it doesn't exist, and then we basically pipe in the output here, fprintf. We just want to print it to the file. Yeah, there we go. There you go. There is the file right there. There is the little rascal. As you can see, we found him right there. Hello world. The same name as this one. I don't know why it bugged out. It kind of just, it was a bit weird, but there you go. So now, as you can see, it works. So there you go. So this is basically how we output something to a file. So everything essentially is a file descriptor. And yeah, I think that's all I wanted to cover. I wonder if I should explain malloc and calloc functions in this video. You know what? I'll take you through those functions when we're gonna be talking about structs and how we actually use them and how we work with them. So yeah, so for now, this is all you need to know. Just a user-defined functions and struct of mainly the file one, because this one's really important. So really go and practice some file IO right here. I should probably also tell you how we read stuff from a file. Yeah. I'm also going to show you how we read stuff from a file. So when you have a file like this, let's actually combine it with user-defined functions. So yeah. Yeah. So hold on tight. I'm gonna show you one more thing because I want to give you like a nice course here that's like really high quality. So I'm just gonna show you one more thing. So we can combine, for example, this file struct with user-defined functions. So we can basically define our own functions that will basically double as for writing files and reading files. So here I can just create a void function for now, for example, and I can be like write to file right here. And here we need to pass in a few arguments. So what we want to pass in here is we want to pass in a const char pointer to file name right here. And we also want to pass this is all that we need. So we don't need anything else. So let's use our file pointer to basically write a file using a user-defined function. So I want to have a function like this. So we only really need one parameter because this function will be used for writing. So let's see. I'm also going to write a string here. So I'm going to say const char pointer data. So this is going to be the data. So the first parameter is the name of the file we want to write into, and the second parameter is the data we want to write into. I have talked about the const char pointers in my first video. I'm not going to go over them anymore. So what we want to do here is we want to, again, open our file pointer to a file. So we want to open a new stream. Use fopens because this is the functions that we're supposed to use now. First, so I'm going to go slow. First parameter is the memory address of our file pointer. Easy. You do an ampersand file. There we go. Then the file name will be file name, and an open one will be append. So we are gonna open this stream for appending. Then I want to do print fs, and I want to basically print to our file stream. So what I want to do is here we want to choose which stream do we want to print into. Well, file right here, file stream. Then we choose the format, which will be string. So I want to print a string into my file because the data is essentially a string. And then here I'm going to write the parameter data. So this is when I want to print to my file. And then at the end, as every good programmer should, we'd close our stream. Fclose file. Make sure to close the file down. We opened the file, we wrote into the file, and then we closed the file. Good. And here, maybe we want to let the user, maybe we can then print another string, let's say. Here, maybe we'll just let the user know that, hey, the printing is done. So, file, write, done. So maybe let the user know that, hey, I have finished writing data to a file. Awesome, great. Now I'm going to talk a bit about how we read stuff from a file, because I think it's good to do this in one video. So maybe we want to write another function that's maybe void, let's say get let's say data from file. You don't have to call these exactly the same as I do, just call them whatever you like. Again, we have to pass in the name, so const char const char data, so file name. Now we will only talk about how we can get one line from the file, because getting all the lines from a file is kind of complicated. And That's kind of complicated and already kind of more difficult. And I feel like if you want to get all the lines from a file, we first need to talk about the basics of getting of one line from a file. You know, let's not get ahead of ourselves. All right, let's first learn how to actually read a line from a file first. Okay, so don't worry, I'll teach you how to read all the lines from a file, but in the next video. Okay, that's for the next time. Let's just cover the basics first. Okay. I know, it's exciting, obviously, to go to to do all this complex, advanced stuff, but you need to have a good foundation first, okay? Don't get ahead of yourself. Let's not get ahead of ourselves. So, all you really need is just the name of the file, right? Because we're not actually writing any data. So, in this case, we'll just pass in the name of our file. So, again, file, pointer, file. You can name whatever you can name this whatever you want, by the way. It doesn't have to be file, but I like using file because it's clear. Then f open. Okay, on Windows, this is for Windows. This is basically Windows specific how this works. So I don't know, maybe Linux will be different, but there we go. Again, memory address to a pointer to a file, so that would be ampersand file. And then here we want to get the reference of the pointer, that's why the ampersand. Then file, then const char file name, which would be file name, and R. Basically open mode R indicates that we want to read from a file. Good. Okay, now what we want to do is say f gets f gets f scan f. I think it's f scan f, right? Yeah. I think this will be f scan f. F gets, right? Yeah. It's f gets. So this one gets one line for me. So for Windows, it's f gets. So what we want to do here is want to say buffer. So as you can see, we need a buffer and the size of the buffer. So max count. That would be basically the size of the buffer that you have. So you remember the buffers last time I told you, like in the last video, how I said that it's important to cover the buffers before. So this is where we build on that concept. So what we need is a char. We need a buffer. So char, and let's say I'm gonna have 24 here. So 20. So I can read maximum 23 chars from the file here. Let's go 128. So here we can read maximum of 127 characters from the file. And since files tend to have a lot of text in them, let's just make sure we allocate enough text, enough space for our text to fit in. Then what we need to do is do a memset. So we set our buffer to 0 to null terminators to make sure that we don't have random garbage in there, because this is this is where we kind of combine all the knowledge together. So here we basically say buffer, then 0, and then size of buffer. And since this is sized right here, we can use the size of operation on the buffer. So great. So now all of the data here is set to 0. Awesome. Amazing. Good. Now we can proceed to write into our buffer. We say f gets, and we say buffer. The buffer will be our buffer that we've declared. Max count will be size of buffer, because this is how many, like we want to grab the amount of data from the file that fits into our buffer, the maximum amount of data from the file that will fit into our buffer. That's why size of buffer. And here in file, we simply just say what file do we want to get. I mean, you can cast this into a file pointer if you wanted to, right here, but this is not what we're gonna do. This is kind of redundant. over here you simply just pass in the file. Like this is all you really do. Like you literally just pass in the file, like the stream that you want to get something from. So I want to get a line from this file right here, from this stream. So that's why it's there. And as you can see, this function returns a char pointer right here. We will talk about that little char pointer right there, return type, later in other videos. It will be important when we're going to try and grab multiple lines from the file, so that will come in play into later. Just keep that in the back of your little mind, you know. Keep that in the back of your head, you know, your pretty little head, you know. We will come back to that later. So okay, great. We grabbed a line from a file, we saved it into the buffer. Now what? Well, we can now close our stream, our file stream, because we're not going to need it anymore. Okay? And now all the line that we have grabbed from the file is now saved here in our buffer, in our variable. And there is a null terminator at the end of the string that we have, right? So now we can just print it out, and there is, without any hesitation, without any hassle, we're not going to be printing any random garbage. So we can just go here and just say, I want to print out my string, and my string is going to be buffer. And here I'm just going to go down here and say file read done. There we go. And I want to terminate this with a new line right here. So basically what happens here, let's I'm going to recap this at the end of the video again, okay? So good. So now we can read stuff from the file and we can write stuff to a file. Great, awesome, amazing. Let's show ourselves how this is done. So let's go here and let's yeah. So we will first write something into a, what the hell? Anyway, we will first write something to a file. So let's write something to our file. So let's use the function write to file. So write to file, we pass in the file name, hello world.txt, that's our file name. You have to pass it in with the extension as well. And then data will be hello world. So that will be our data that we want to write to our that will be the data that we want to write to our yeah. So that will be the data we want to write to our file. And then we just simply run our program, and you'll see that a little file will appear right here. There we go. Hello world. Awesome. Perfect. Now, if you have done this, you have successfully wrote a function that will write into a file. Awesome. Let's read stuff from the file now. So we have successfully used this function to write something to a file. Let's read it from. Let's actually read something from this file, right? So let's say get data from file, and then here we just simply pass in a file name. So our file name is hello world.txt. So this is the file we want to read data from. And if we run this, it should simply print hello world. There we go. Prints hello world, and it says file read done. So I hope you followed with me, you know, of what I'm doing. And as you can see, we indeed get hello world, and it says file read done. Okay. I hope you followed with me. If not, that's fine, but I hope that you are at least trying to kind of do this yourself. As you can see, we have now successfully managed to write something to a file and read something from a file. So let's do a little recap. So now we should know the difference between the int pointer and passing arrays to our function as parameters. You know, you should be able to now obviously initialize arrays and set data to arrays. using user-defined functions. We also talked about the difference between the size, we use the size of operator correctly, which should be, you should use it on sized initialization like this, not on this type of pointer, so this is wrong. We also talked about how everything in C is a file, so, file descriptor 0, 1, 2, and how that plays a role. And now let's recap so let's do a little recap here of everything. So std in, std out, and std error are all file descriptors. Descriptors. But you can also make your own file descriptors by using the file struct pointer like this. So you can use this to make your own file or your output where you want to save. Then, obviously, we have already discussed how int pointers are also arrays, and how you're passing a pointer to an array when you're passing it as a parameter. Now let's discuss this. So this is I think this is a lot more difficult, so let's recap this. So what we are seeing here, well, first we have basically we basically have made a function called write to file, which writes data to a file. So as you can see here, we declare a file descriptor or a file stream like this. This means that we can now create a file in our operating system that will contain the data we give it to. We use fopens, we pass in the memory address of the reference to a pointer, this guy right here. As the first parameter, we pass in the file name, which is from here, so we use that as a parameter. And then mode is going to be append. We also use the second parameter to pass in the data that we want to write to a file. Then we use fprintfs or fprintf, which is basically a file print format. So we pass in the file, and remember this could be stdin or stderr, not stdin though. Not stdin, this will not work with stdin. So this will kind of be this fprintfs takes either standard out or standard error, or a pointer or an IO buff pointer or a file pointer, to basically if you want to output the results to your own files. And obviously it also takes the data right here, so you put the format and the data into the var args right here, which is the data you want to write to a file. And then, as any good programmer will do, we'll close the file stream, and then we will tell the user that, hey, we're done writing to our file. Then we want to read stuff from a file, obviously. If you're writing stuff to a file, we obviously want to read things from a file, don't we? So here, we declare a buffer, just like we did in the last video. We say 128. Then we set all of that 128 bytes to 0. And then we basically declare a file pointer and do the same thing. So fopen, which is basically open a file for reading in this case. And here we basically say, we pass in the reference of the file to the first parameter, give it a file name, and then this time we do R. Remember R for read, so don't forget about that. Then fgets, we use the fgets function, which will get one line. So this will terminate read after a new line character rather than after a space. And we basically want to grab 128 bytes or 128 bytes worth of data, or in this case 127 characters from our file. And so this is basically how much stuff do we want to grab from the file. So fgets goes the buffer you want to save the data to, the amount of stuff you want to get from the file in bytes, and the file that we want to grab stuff from. Okay? And then fclose, obviously close the file stream. This is the Chad move right here. So if you want to be a Chad, you always close the file streams, okay? Like forgetting to put put the f close there that only virgins do that. It's a virgin small pp move. Okay, so remember, if you want to be a Chad, always put f close. That's a good way to remember that. And here we just simply print our data from the buffer that we've saved, that the fgets function saved it there for us, and then we basically just say, hey, read is done. And that's basically how this works. I will obviously have some contact information in the description of this video as well, just like with the last one, just so you can ask me any questions if you still don't understand it. I will probably answer it. Well, I'm gonna try my best. But yeah, this concludes the end of this video. So well done if you made it this far. Good job. I'm gonna give you an applause because this is very hard. Because this was very difficult. Like, this was hard. Yeah. So give yourself a little applause and a pat on the back because you're doing well if you got this far. So next video will be about malloc and cealloc. So prepare your souls for that. And heap allocation, and also I want to take you through a bit more advanced concepts of C, like maybe getting all the data from a file line by line, and so on and so forth. So I'm also planning to do a little series on all three C languages, so C, C++, and C#. That would probably be... Yeah, that'll probably take a long time because there's a lot to cover in the C languages in general. They're very big, very robust programming languages, and it takes a lot of time to cover it. So we'll get through it. You know, it's probably going to take like 1,000 years, but, you know, we'll get there eventually. So yeah, next video will be about cealloc, about malloc, heap allocation, how we actually work with, some more advanced concepts, and structs. So get excited. So now this is getting exciting already. This is the exciting part, structs in C, and how we actually define our own structs. And then I will teach you how to make a network client, an actual functioning network client in C for Windows specifically, okay? So there's a lot to be excited for. We're going to make a client and a server in C that can talk to each other. So that would be like the final sort of project that you can make alongside with, if you can make with me if you want, or we can do together. So you can code along, and maybe you will be able to also code your very own first network client in C. It's actually, I'm going to give you a little hint, it's actually not as hard as you might think. Trust me, it's not as hard. It's really not. Like C is not difficult, okay? The C languages are not hard. What they are is, in my opinion at the very least, they have a very steep and very large learning curve. And I think that is what puts a lot of people off from programming in these. They're not hard. They just have a lot of stuff. And that stuff is confusing. And that definitely is true for C++. Like, Jesus Christ, what the hell, dude? Like, they add, like, C++ has so much shit in it that, like, it's insane. So, they just have a very steep and very large learning curve. But they're not difficult. It just takes a lot of time to understand it. So, there we go. So, I hope this kind of helped you a little bit about understanding more. So, next video we'll get into the more interesting stuff, structs and all that. And we will code a network client in C, so you can maybe follow along and code along. You know, maybe you can look up equivalent libraries for Linux, the Linux users, and yeah, or maybe I'm just gonna straight up show it to you for Linux. We can maybe code both Linux sockets, and we can also code Windows sockets as well. So, yeah. So both of you will get a little tutorial equally. We're also going to look at multi-threading in Windows. So we'll look at the pthread, the pthread library. So for Linux, it's pthread. and for Windows it's process.h. So we're going to look at these two libraries. So for Windows you include process.h. So process.h, and here basically there is this little function called, I think, begin thread. And here, as you can see, it takes in begin thread proc type. So we will look at, this is basically just a pointer to a function you want to run on a different thread. But we will look at this later. So this is when we're going to be looking at function pointers and what they are, and we will basically show the little multi-threading capabilities of C. But that is for the far future. For now, go back to the last video and practice that, and go through this video and practice this, okay? For now, this is all you really need to know. Don't worry about all that fancy schmancy nonsense. So, see you. So, I am gonna leave you, unfortunately, and see you in the next video, probably about Python or whatever the fuck I decide to make. So, yeah, I'm gonna go now, and I'm gonna go and stand upside down on my roof, on the ceiling on my room. So, goodbye.